So, hello, we're gonna begin. Hi, the theme of my talk is Gomobile, Gophers in the land of Android. Gophers refers to people who do Go programming language. My name is Jovica Popovic. I'm head of mobile apps at -5. We're a technology company from Zagreb, Croatia. We mostly do work in sports and sports betting. If you want to work in Go and live in Zagreb, come talk to us. So, Go programming language. How many of you have heard about Go? Okay, knowledgeable crowd. How many of you have actually worked in Go? Okay, you can check your phones for 5 minutes while we go over the basics with the others. So, what is Go? Go is a compiled language, which means a compiler compiles it to a binary for the target architecture. It doesn't run in a virtual machine like Java or JavaScript. Go is also statically typed, like Java, unlike JavaScript. Go is statically linked, meaning that compiler compiles a single binary that you get for your target architecture, and if you copy it over to a server and run it, that's all you need. There are no external libraries, packages, things like that. Go is like all modern languages, memory managed. Go was originally systems-oriented, meaning it was meant to be a rather low-level language to be used on your back-end, on your servers and things like that. But lately it's evolved beyond that. So, let's go. But why? Why should we care? What does Go bring to the table? Why should it be interesting for us? Well, a couple of reasons. One of them is efficient compilation. If you have any non-trivial Android applications, you know that between the moment you press run and you get your application running on your device can take somewhere around a minute to maybe more if it's a more complex application. Even rather complex Go applications compile in a matter of seconds, literally seconds. You press compile, bam, it's done. Go is efficient at execution, meaning it's fast. One of the main features of Go is ease of programming. If you've never seen a line of Go code, you can go from there to being a fully functional programmer in Go in a matter of days, a couple of weeks tops. So it's very, very easy to pick up. That's a function of a couple of things. One of them is low verbosity. Go doesn't have much instruction statements, things like that. Formatting is very strict, so you don't have to think about how do I write this, how is this formatted. It has a very few concepts compared to the other modern languages. There are no exceptions, there are no classes, there are no inheritance, there is no polymorphism, and all of the other things. But one of the main strong features of Go is its strong concurrency features. Whereas in a regular Android application, you might have a couple to a dozen threads running at the same time. At Go, it's not uncommon to have 1,000 concurrent execution elements. They're called coroutines. Complex, big programs running on servers can have 100,000 parallel execution units without breaking a sweat, which is science fiction, basically. Go also features advanced tooling. Out of the box, you get formatting, error checking, performance measurements, benchmarking, race condition checking, many things that really help you with your everyday work. So, a brief history of Go. Go was actually conceived while these three guys were working at Google and while literally their code was compiling. At the moment, all of them worked at Google on a big C++ project, which featured a compile time of 45 minutes. And while they were sitting in the office and thinking how that cannot be good, they came up with a list of things they want to do differently if they designed a modern programming language, modern systems programming language from scratch. First of the guys, Ken Thompson, you might have heard of him. He's basically one of the guys that invented Unix, so he knows what he's doing. Rob Pike, he's the guy that made Plan 9 operating system, which is operating system that nobody uses, but everybody copies from. Both of those guys, they invented, among other things, UTF, which all of us use for encoding. And they started playing with Go, and by 2009, they publicly released it as an open source project. Now it's hosted on GitHub. You can pull down the source, make a contribution, and be a contributor to Go. In 2012, version 1.0 was released, and Go was officially deemed ready for production. In 2015, version 1.5 was released, and it had full support for mobile targets, iOS and Android. And from then on, Go really took off. So by 2017, it's featured in many top languages lists. It got many awards. And our company, first production deployment we had in Go was 3 months after version 1.0. By 2014, we completely migrated our backend services to Go, and last year we started with first experiments with Gomobile, with Go deployed on mobile devices. So, adoption. Do people really use Go? Well, these are only some of the companies and products that rely on Go. I got bored copying and pasting all the other logos, so there are many more of them. You'll notice, for example, there's Basecamp, which are guys that invented Ruby on Rails. Docker is made entirely in Go. Kubernetes too. And basically every big company in the world is now experimenting with Go. So let's see what Go can do for us. Gomobile is an experiment. Gomobile is not yet deemed fully production ready, although in our case it proved it is. So let's start from the beginning. What is Gomobile? Gomobile is a tool for running Go code on mobile platforms. It's a Go package that you download, install, and it enables Go code to run on your mobile devices. At the moment, it supports Android and iOS, and it supports native apps and libraries too. But why? Why should we be thinking about using Go on mobile? Maybe Java is quite okay. But maybe we have some cross-platform solutions that we need to implement, or maybe our backend already implements some components that are written in Go, so we can take those out as a package and reuse them on our iOS, on our Android applications, without making the same thing 3 times. There's also a package that cross-compiles Go to JavaScript. It's Gopher.js. You can look it up, and it enables you to run equivalent of Go code on the web. You may have some existing Go library. Go comes with a fairly standard rich library that enables you to do many things that are really hard, but people did it once and did it well. You may have complex concurrency requirements that are difficult or impossible to achieve in plain old Java. You may need access to large amounts of RAM. Go is running on your mobile phone as a native process, so it doesn't have memory limitations that Java programs running on ART have. You may need to employ OpenGL applications. So Go also has bindings for OpenGL. And lastly, why not? It's a modern, up-and-coming language. You may want to experiment with it and see where it takes you. So, if we really want to use it, we need to set up and get things rolling. A couple of prerequisites. Of course, you're going to need Android Studio. You're going to need Android native development kit. And you're going to need installation of Go on your machine. 1.5 is required, but current version, which is 1.8, is recommended to get all the latest goodies. Process of installation itself is really rather simple. If you set up everything Go and Android Studio correctly, you just go into a terminal and type go get, and this is the address where the package is. Go will download the package, compile it to binary for your target machine, and after that, it's ready to run. You then type Gomobile init to instantiate initial stuff that it needs to run, and you're good to go. That's it. Minute and a half, you're ready to run. Usage is also rather simple. Also, from the command line, you type Gomobile, give it a command what to do, and that's it. Available commands at the moment are here, and we're going to go over them later in a demo. So, what can we do if we really want to do Go on Android? We can make native Go applications. For that, there's the Gomobile build command that you provide with an output, which is the APK that you need to be built, some build flags, and name of the Go package that you want to build as an Android application. What that does, it generates an APK ready to install on your device. So you type Gomobile build, name of the package. A minute later, you have an APK that you can run on your machine. The package must have a main function, which is the entry point for the executable. And you can also have assets in a directory pack which will get to your APK, so you can distribute by other assets like pictures and things like that. And if you have no special needs for your manifest, it will also be automatically created by the Gomobile package. So it's really rather simple. Of course, there are rather, at the moment, limited capabilities regarding what you can do once you're running natively on Go. And these are some of the things that are available right now. But my guess is that will probably expand in the future. But what's really interesting is using Go as library project for our regular Java SDK application. So that works something like this. On one side, we have Go. On the other side, we have Java. They don't know how to talk to each other. But thankfully, they both have a mutual friend, which is C. If you ever worked in Java NDK, you know about Java native interface, which allows you to integrate C programs into your Java code. On the other hand, Go has CGo, which is a package that allows Go code to talk to C. So we use their mutual friend to have them to talk to each other. Gomobile doesn't generate C code. It just uses the common interface to have them talk to each other. Usage is also rather simple. From the command line, you type Gomobile and bind the package for Android. Give it a couple of flags, the name of the package, and moments later, you have an Android archive generated, which is importable into Android Studio. And in it, you will find all of the public methods and structures from the Go package exposed to your Java code and available for you with auto-completion and everything like you normally have for any other library that you have in your project. Also, you get the assets directory and all the assets contained there. There are a couple of problems or challenges. One main of them is limited type support. At the moment, you can only expose limited type of variables or structures or methods. Those include integers, floats, strings, and byte slices. The biggest and most painful omission is no array access. So if you need to transfer arrays, you have to do some tricks. We'll get into that later. Also, your projects must use min SDK of 15 or greater, but since this is 2017, that's not really that much of a limitation. And also, Gomobile builds fed binaries. It means it builds executable binaries for all the supported architectures. We'll talk more about that later. So let's see that in action. So here this is, the editor is Gogland, which is early access preview IDE for Go made by the guys we all know and love, JetBrains, which are the greatest. Thank them for it. It will come out as version 1.0 sometime this year, but it's available to download now, and you can use it. It is usable. So here we have a Go package. And this is first we're going to build a native application using only Go code. So this is our main. Can you see this? Yeah. Okay. See, this is our main function where the entry point of the application is. Gomobile defines, gets us an app package, which within itself has a main function, which exposes a channel of events that allows us to interact with the system. And on that channel, we get, I'll talk about what channels are a bit later, where we get events from the OS, from Android, to tell us what's going on. One of the events are lifecycle events, which you all know from activity lifecycle. And there are paint events, which inform us that we need to paint the display. And there are touch events which provide us with interaction with the users. As Gomobile, as of now, only allows OpenGL to be used as a display. And since OpenGL is a bit beyond the scope of my presentation, we're going to ignore display for now, and I'll use the opportunity for this native application to showcase some of the advantages of using Go. So in our main application, we are waiting for touch event, and when we have end touch event, we're going to do something. And that function is here. This is a function that will first take the time when we entered, and then run a pool which will have 1,000 workers, and it's going to dispatch 3,000 tasks for them. So we're going to have 1,000 concurrent threads in our application. Actually, threads in Go that don't exist as such. Go runtime uses threads, but it distributes coroutines to those threads dynamically. So we will not have 1,000 threads. We're going to have 1,000 parallel executions in our applications. And we're going to run that pool, and when it's done, we're going to take time how long all of the process took. The process is building 1,000 threads, distributing work to them, and shutting them all down. So we're going to here, let's say, Gomobile, install Android native. And hopefully all will be well. And Gomobile will use the connected emulator and install a package on it, which will then run. Actual Go compilation is very fast, as I said, but we need to build the APK and install it on device and everything. So we got success, and now we can run our Android app. We got the default icon and name, so here we go. This is our applications. I'm going to switch now to Android Studio so we can watch the output. We're going to log what's going on. And when I press, we will instantiate 1,000 workers and distribute 3,000 work units to them. And that's it. Go did that in 43 milliseconds. So it took 43 milliseconds to instantiate 1,000 threads, distribute 3,000 works units to them, and shut it all down. Which, if you think about doing the same thing in Java or using threads or, God forbid, async tasks or things like that, that would not scale so well. So let's see how Go does that. This is our application, and this is where we instantiate our pool. Our pool function looks something like this. It takes number of workers and number of tasks as an input. And here we are making a channel of ints. Channel is a method for Go coroutines to talk to each other. Something like Unix pipes, if you're familiar with them. So on one end, we pump ints, and on the other end, those who read from that channel get those ints. So here we instantiate a wait group, which is a semaphore, something that we use to synchronize all the running threads. And in the loop, we instantiate our 1,000 workers. First, we add for each of the workers one semaphore count up, and then we instantiate the worker. The important thing to notice here is Go statement, which means run the following statement as a coroutine and return immediately. So when we say Go function worker ID, immediately afterwards, the control will go back to the loop and it will continue working, instantiating new workers. And new workers will be instantiated one after the other, and we will exit the loop here with our 1,000 workers created. After that, we go to the other loop and distribute tasks by simply writing into the channel. We write into the channel a series of ints which represent some work. Could be URLs to fetch or, I don't know, things like that. And let's see how the worker looks like. Worker is rather simple. Worker takes two arguments. One is ID, so we know what it does, which worker it is. And the other variable is channel, which we define as channel type of int, and we read from it. This direction of the arrow indicates that we read from this channel, so we cannot write to it. And now each worker starts a loop, which does range, meaning read from this channel until until the channel is open. So it simply loops in this loop, gets the work. When it does the work, we represented the work by sleeping for 4 milliseconds, so it does something, it doesn't exit immediately. And this is it. This is all of the magic. This is how we distributed 3,000 work units to 1,000 parallel executions, which is, if you can see, some 15 lines of code. So you know how much we would need to do the equivalent thing in Java. So now that we see that we can do exciting things with Go, Let's see how we can connect that to our regular Java apps, because even after all is said and done, you're still going to use Java to produce user interface to interact with system services and things like that. So we have a simple Go library, which we defined here. We have, for example, one function which is echo, which just returns what we sent to it. We will use that to demonstrate how to call from Android to Go. And you'll notice that the function has a capital first letter. This is one of the things when I said Go avoids verbosity. There are no public, private, or package modifiers in Go. If the function or a variable or a struct has a capital first letter, that means it's exported or that it's public. If it's small letter, then it's private. And that's it. There is no other magic to it. So we have one function that just returns what we have. But having the ability just to call from Java to Go wouldn't be nearly as useful as being able to call from Go into Java. So we need some kind of mechanism to enable two-way communication. We do that with what we all know, and these are callbacks. We define an interface, Java callback interface. It doesn't have to be called like that, just descriptive. Also, you'll notice again, it has a capital first letter, which means it will be exported. And in that interface, we define that the interface needs two functions. One is heartbeat, and one is relay message. And so Go can call those functions on that interface wherever he gets it. From Java, from Go, it doesn't matter. And we have another exported function, which is register callback, where Go gets a callback variable and stores it. And just so it does something interesting with it, we here have a new ticker, which does exactly what it says to. It ticks every 500 milliseconds. And we range, this is again a loop using that ticker, that every time we get a tick, it will, on the callback, call relay message and call heartbeat. We also, for good housekeeping, have unregistered callback functions, so we can stop the connection to Go. And this is it. This is complete library that we can use in our Android application. So let's build a library. So we need to tell it where to put the library, because I already made the Android project. I know where to put it. And the package that we want to build, it's called Android Library. I think that's it. We'll compile the Go package. It will generate a C interface for Go. It will generate JNI interface for Java, package it all into an AAR, and there it is. It's done. So now we can switch over to our Android application, where we need to incorporate that library. So first in our build Gradle file, we tell it where the directory with the library is. And in our app Gradle file, we tell it to compile the library. And then we do the sync, so it reads the library, explodes it, and see what's in it. And after that is done, in our main activity, after that is done, we have access to all our exported functions and methods and structures from the library. And they are available for us with auto-completion. So here are all our functions. Also, our Java callback is there. We can even, as we all know, control-click and look what's in the library. And so I made a simple user interface for the applications where we have one button that does reading from the text on the form, calls the echo function that we defined in the library, and prints out the output in the other view text. And also, we have two buttons that register and unregister our callback, which is, as we've seen in the library, just simply register callback with our Java callback that we instantiated here. And this is simply like any other class that you instantiate after you create it. Android Studio will say, do you want to create the overrides for the interface? You go Alt-Enter, and you get all the classes pre-filled for you. And when we press the heartbeat button, since this is on the other thread, we need to run on UI thread where we can toggle a check text. So let's see how does that do. So now our application is compiling. It's done, and now it's installing, and here it is. So if you say something to Go, for example, Go, hello, Go returns that we said hello, so we have communication. If we do the register thing, we see that we get callbacks from Go code into our Java applications. So this is something that enables you to do pretty much anything that you would need in Go. So this is it. What I find interesting and possibly useful is if you do, while you build the library, if you give it a work switch, oops. Oh, my bad. I have the wrong place. If you give it a work switch, it will keep the work library that it creates while it does its thing. So you can inspect the code that it created, and that way you can use it to debug and find if anything isn't working as it should. So this is the directory where it worked. So if we go there, you will find an Android directory there, and there it will be our sources for our libraries that we created. So if you go into here, all the functions and variables and everything that's exported is listed. So if anything doesn't get into your library and you think it should be, you look here, and you will get a message why something wasn't exported. In your Go library, you can use other types and other functions that use unsupported types for communication, but in those calls that are not exported. Only exported ones have the limitation on types. Anything that's just strictly Go code can use anything that Go uses. So any library from the standard library of Go, you can use it there. So that enables you to have net calls, to do cryptography and all the other fun stuff that Go knows how to do. And here you will find, if you go, no, sorry, not here, here, JNI libs. This is the actual Go code that got compiled into binary for all the platforms that Gomobile currently supports, which is 32-bit ARM, 64-bit ARM, x86 30-bit, and x86 64-bit. So since these libraries are not that small, a couple of megabytes each, if you include this in your application, you're gonna make it maybe a bit bigger than you would like. So then you can use the option of splitting the APK into other platforms, so you have smaller libraries. And this is our conclusion of our demo. So here are some caveats and gotchas that you need to take care if you're working in Go. This is what I talk about, the fat libraries. So you can split them up into different CPU architectures to manage the size. You need to avoid underscoring in package names because of the way Gomobile decorates the names. It won't work. I learned that the hard way. Be careful with your data types. Double check what got created in the translation. So int translate to long. So you need to do int 32 or int 64 in Go to make sure what you're going to get out. Also, consider the performance of frequent calls into Go. Since Go talks to Java over JNI bridge, it's in a different process. So every call into Go goes over process boundary, which is rather expensive. You don't want to do that 1,000 times a second. You need to think of some strategy to limit the number of calls into Go. If you really need array access, you cannot export arrays into Java, but you can make two functions. One can be get size to know what the size of the array is, and the other can be get the element at position n. So that way you can have array access for Go. Or if you need to transfer complex structures, you can use byte slices to serialize those complex structures into JSON or flat buffers or message pack or whatever you internally use in your application. And use verbose and work bind switches to inspect the output for clues if something isn't as expected. And that's about it. Any questions?